So in Unit 1, Module 4, I'm going to talk a bit about the history of software engineering and project management. The first real-time general-purpose digital computer was designed as part of the SAGE program. This is a missile defense program that started up in the 1950s in the United States. SAGE stood for Semi-Automatic Ground Environment. Think of the big display in Dr. Strangelove, if you've seen that movie, where you can actually see bombers on their way towards the United States, or Russia for that matter. And this program invented actually quite a substantial number of things. They invented modems, they invented interactive displays of the kind that you can see on this screen, and it was a very large software project. They wrote 500,000 lines of code, and they trained up more than 10,000 programmers. Before the SAGE program, there were very, very few programmers, and the SAGE program had to essentially find people who might be able to become programmers and train them up to learn how to develop software. One of the programmers on the SAGE program was Margaret Hamilton. So she worked at SAGE in the early 1960s, and then she went on to become a director in the MIT Instrument Laboratory on the team that was responsible for building the software for the Apollo program. So the Apollo program was the program that took humans to the moon for the first time, and it needed substantial amounts of software built primarily for the guidance computer, both for the Apollo rocket and for the lunar lander. So here's Margaret Hamilton standing next to the source code, or a large chunk of source code from the Apollo program. And she basically invented the term software engineering to describe what her team was doing and to help give it some kind of credibility. There were, again, lots of firsts here. The Apollo guidance computer was the first silicon-based computer using Fairchild NOR gates, and you can actually download this source code. It's on GitHub. If you follow this link, bit.ly/agc-code, it'll take you to an article from where you can navigate to the source code on GitHub, and there's even a simulator you can run on your phone. So this is one of the first historic uses of the term software engineering. But already by the late 1960s, there was what was called a software crisis. And so the NATO Science Committee had two conferences in 68 and 69 to describe this crisis in software engineering, which was that it was so difficult to run large-scale software projects. They would always come in late, over budget, hugely problematic, and they were trying to work out how they could bring these programs of work under control. One of the earliest papers describing a project management approach to software engineering was by Dr. Winston Royce, and this paper is often cited by proponents of the waterfall method of software project management. And you can see this diagram in Royce's paper, which looks very waterfall-y. So these are the implementation steps to develop a large computer program for delivery to a customer. And the term waterfall comes from the fact that it looks like water falling down a slope. So this is the idea that we're going to break up the software development process into a series of phases, and we're going to finish one phase before we start the next phase. We're not going to go backwards. We're going to get everything done rigorously before we move to the next step. That kind of rigor around the separation of the phases is sometimes called phase gate. So we have gates and we don't go through the gate until we're done with one phase, and then we don't go back. So Royce describes this in the paper, and he says fairly early on, just before halfway through, I believe in this concept, but the implementation described above is risky and invites failure. So already at the beginning of Waterfall, we have people talking about it, discussing the potential drawbacks. And so Royce goes on in the second half of the paper to describe an approach that he thinks makes more sense. And the final diagram is actually a lot more sophisticated than a waterfall proponent might make you think. And you can see on the right, there are some countermeasures that Royce recommends to help make this work properly. So he does say complete program design before analysis and coding begins. And that the documentation must be current and complete, which sounds pretty traditional from a project management approach. But he says in step 3, do the job twice if possible. And the reason he says that is because you're going to learn a bunch of stuff doing it, and your first effort probably won't be that great, but your second effort, you'll be able to benefit the second time round, you'll be able to benefit from what you learned the first time doing it. And so what this is basically saying is the first time round is a prototype. And in the prototyping phase, you're going to learn a bunch of stuff that will let you do it properly for real. So doing as a form of risk mitigation, learning by doing. He says that testing is a significant problem because you're going to find a whole bunch of stuff that you couldn't find earlier on in the design phase. And so testing often went out of control in those early days, as it still can. And so that has to be planned, controlled, and monitored to make sure it doesn't go out of control. And then step 5, involve the customer. So again, we're seeing something which these days, user experience design is central to software development. But even in 1970, Royce was saying, involve the customer throughout the process. And that really is one of the foundations of the agile way of thinking about software development. So already in 1970, we're seeing the drawbacks of a rigid phase gate approach to waterfall, and we're seeing ideas that now are very common and popularized by the agile movement, like iterative development, where we work in iterations involving the customer all the way through, being proposed as ways to mitigate the risk of following a very rigid process. Now, the very rigid process of waterfall that Royce proposed and then immediately discussed the limitations of is still in widespread use today. So I go and give talks all over the world to all kinds of companies, and I went to Japan a few years ago and went to visit a large Japanese consumer electronics company, and they were still using waterfall to build their products. So this is now sometimes called the V model. So you'll see this phrase V model, but it's basically waterfall. And the idea is, again, we have this very rigid approach to the phases of the software delivery process where we finish one and start the other one. But you can see in this diagram that we have different releases of our product. So release 1, we go all the way to the end, and we don't want to wait until we've released the first version of the product to build the second version, because that'll take too long. So what they've done is they've started gathering requirements for the second version before the release of the first version. And they've done it as early as they can, which is just halfway through implementation, more or less. So we're going to get some of the lessons we learned from implementing before or as we do the requirements gathering for version 2. But there's still a huge problem with this, which is that the lessons we learn after we release version 1 won't count towards the requirements of version 2. Instead, we have to wait until version 3 requirements gathering before we can incorporate the lessons we learned from the release of version 1. So that's hugely problematic. I mean, if it's taking 6 months to do a release here, and that's honestly pretty optimistic, we're going to have to wait 12 months after we start building this product until we can release a version that incorporates the lessons learned from the first version. So that's hugely problematic, and it's one of the reasons why this way of delivering software is not used by high-performing organizations, simply because the feedback cycles are too long and your competitors are going to be able to iterate and learn and deliver much more quickly than you, and that's going to make them help them build much better products. There is commonly criticism of software development from people involved in manufacturing or architecture or designing buildings, and from within the software engineering community as well. Why can't we be more like civil engineering, where things get built and they generally stay up and they generally work? And it's important to remember that that is true in civil engineering for projects which are very similar to ones that have been built before. But when you're doing civil engineering with radically new ideas, with innovation, that's not how civil engineering works. So some of you, I'm sure, will have visited the Sagrada Familia Church in Barcelona. That church is not complete yet, despite being under construction for over 100 years now. It was designed by Gaudi, and Gaudi famously said, "My customer is not in a hurry." So Gaudi was a really amazing architect, and he built his designs in fundamentally new ways, and he leveraged new and invented new ways of designing structures as part of his work. So when he was building churches in the beginning and other kinds of buildings, the typical style focused a lot on right angles, building things in a very linear right angle based way. And he was very interested in how things work in nature. And he noticed that in nature there was lots of parabolic structures and hyperbolic structures. And he went on to design buildings that used parabolic and hyperbolic curves in their structural design. Now, this is very new, and you don't want to build a building using fundamentally new design techniques and then find out that they don't work. So he invented a whole series of techniques to experiment with new designs. So if you go underneath Sagrada Familia into the crypt, you can see he would build scale models, which would, excuse me, which would allow him to simulate the loads on the structure to check that the structures would stand up under load. He had tons of prototypes and scale models to test out his ideas, and he built small versions of his structures to make sure that they would stay up and bear load. So you can see, even in civil engineering, when you're innovating, you're going to use a lot of the techniques that we talk about in product management, where we were very much inspired by this kind of approach of prototyping and finding ways to run experiments to gather data before actually building the thing. So these ideas in modern product management aren't new. They're ideas that people have used for a really long time, and that we've talked about and used in software engineering for decades as well. What's happening now is that they're becoming a lot more popular. They're innovations that are moving up the S-curve and becoming more widely adopted, if you like. And so that's why you're seeing that they're much more pervasive. They're not always the right thing to do. People often ask about, where do we use waterfall? Where do we use agile and lean methods? And the answer is, waterfall is effective where you can do most of the risk mitigation through an upfront planning process. That's generally only true for projects where there's not major innovations. Because where there's major innovations, you're typically, because of the complexity of software projects, going to discover things through building them and through operating them and through customer interaction with the finished product that you couldn't possibly find out through upfront design and planning. So things where there's major innovation, or where the product is expected to evolve substantially over the course of its life cycle. So those are areas where you really need to apply this lean, iterative, agile approach. In this book, Testing Business Ideas by Bland and Osterwalder, you can see this nice diagram, which is a high-level picture of the general approach that we take in product development, where we're ideating and coming up with prototypes and assessing them, and then we're designing experiments and running tests and learning, and we go through this kind of two-sided loop at multiple levels. It's kind of a fractal process that we go through, but this idea is, again, that we're coming up with ideas and then testing them and iterating so we can learn really fast. And so this idea is at the heart of the lean startup method and at the heart of lean approaches to product design and agile software development. But again, they're not new. In Tom Gilb's book, Principles of Software Engineering Management from 1988, he talks about how we have to use an iterative approach to software design and development. We must set measurable objectives for each next small delivery step. Each of these are subject to constant modification as we learn about reality. It's simply not possible to set an ambitious set of multiple quality, resource and functional objectives and be sure of meeting them all as planned. This is the software crisis problem. We must be prepared for compromise and trade-off. We must then design or engineer the immediate technical solution, build, test it, deliver it, and get feedback So this is Royce's idea that we have to go through the process twice. This feedback must be used to modify the immediate design if necessary, modify the major architectural ideas if necessary, and modify both the short-term and the long-term objectives if necessary. So already in 1988, Principles of Software Engineering Management, we talk about how we have to take an iterative approach to software development. And Tom Gilb's book was one of many books that discussed what was called lightweight approaches to software delivery, where we take this iterative approach. And a whole bunch of people involved in those methods got together and put together a manifesto in 2001. So this is the manifesto for Agile software development. We're uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value, and then there's these 4 trade-offs. And it's important to note in these trade-offs that it's not saying the thing on the left is good and the thing on the right is bad. That's not what's going on here. Underneath it says, that is, while there's value in the items on the right, we value the items on the left more. So individuals and interactions over processes and tools. So it's not that processes and tools are bad, they're good. But what's more important is individuals and interactions. So we see that all the time today. People are really keen on tools, they're really keen on implementing processes, but those on their own don't achieve results. We need teams, we need people, we need communication, we need process improvement, we need to change the way we do work in response to the tools in order to be successful. Number 2, working software over comprehensive documentation. It's not that comprehensive documentation is bad, it's good. It's just that working software is more important. Customer collaboration over contract negotiation. Contract negotiation is inevitable, that's fine, but it doesn't prevent you from having to work continuously with your customer over the software development lifecycle, which again Winston Royce talked about, involving the customer from the beginning and throughout the process. And then finally, responding to change over following a plan. That doesn't mean planning is bad, planning is good. It's really important to create a plan. It's just that no plan survives contact with the enemy, as very famously was said by von Moltke. You've got to have a plan, but you've got to be able to adjust it in response to what you learn when you execute it. So you've got a plan, but then you've got to be able to respond to change when you put the plan into action and discover the shortcomings. We've got to learn by doing. So 2001, Agile Software Development Manifesto came out, but the ideas behind it go back decades and were in use long before that, and the theoretical underpinnings come long before that. However, it is pretty much pervasive throughout software product development in modern times. Although, as we'll see later on, while everyone says they're doing it, it's not necessarily the case that they're actually doing it, and so you do have to watch out for that.